Problem 37. Jerry Smith has done some analysis about the profitability of the bicycle shop. If Jerry builds a large bicycle shop, he will earn $60,000 if the market is favorable, but he will lose $40,000 if the market is unfavorable. The small shop will return a $30,000 profit in a favorable market and a $10,000 loss in an unfavorable market. At the present time, he believes that there is a 50-50 chance that the market will be favorable. His old marketing professor will charge him $5,000 for the marketing research. It is estimated that there is a 0.6 probability that the survey will be favorable. Furthermore, there is a 0.9 probability that the market will be favorable given a favorable outcome from the study. However, the marketing professor has warned Jerry that there is only a probability of 0.12 of a favorable market if the marketing research results are not favorable. Jerry is confused. Should Jerry use the marketing research? So you'll note from the diagram that I have inserted the numbers for favorable and unfavorable markets for every one of the scenarios and the probabilities. So going through this problem, you'll see if Jerry builds a large bicycle shop, he will earn $60,000. So I'm going to start at the bottom here with no survey. A large shop, a favorable market, is $60,000. If the market is unfavorable, though, he will lose $40,000. A small shop, he will earn $30,000 profit, but will lose $10,000 in an unfavorable market. If he builds no shop, the profit is zero. And then he also knows that there's a 50-50 chance of a favorable or unfavorable market. So that is why I've inserted the 0.5 for each one of these probabilities. Now let's go to a scenario where he does the market survey. Two things at play here. One is that the cost of the survey is going to be $5,000. So if I do the survey, rather than earning a profit of $60,000, my profit is only $55,000 because I need to reduce my profit by the cost of the survey. Same thing, whereas before I was going to lose $40,000 in an unfavorable market, because of the cost of the survey, I will now lose $45,000. If I build no shop at all, because the cost of the survey is there no matter what I do, I still lose $5,000. Whereas before I would come out with zero, now I lose $5,000. If I build a small shop, in the past my profit would have been $30,000. Now, because of the cost of the survey, it's $25,000. I also increased my loss by $5,000. And again, if I don't build any shop, I still lose the $5,000. Here are my numbers for the small shop once again, and the probabilities that I've been told by the professor for each one of these. The next step now is to start calculating the numbers for each one of these decision points. I'm going to start at the top at decision node number 2. Node 2. I take 55,000 times 0.9 plus minus 45,000 times 0.1, and my number for node 2 is 45,000. Let's do node 3. Node 3. 25,000 times 0.9 plus minus 15,000 times 0.1 equals 21,000. Node 4. 55,000 times 0.12 plus minus 45,000 times 0.88 equals minus 33,000. Node 5, 25,000 times 0.12 plus minus 15,000 times 0.88 equals minus 10,200. Node 6, 60,000 times 0.5 plus minus 40,000 times 0.5 equals 10,000. And node 7, 30,000 times 0.5 plus minus 10,000 times 0.5 equals 10,000. So what do I do with all these numbers? First thing I have to decide is which of these shops to build. So here my node 2 is $45,000. No shop is minus 5,000, and a small shop is 21,000. I'm going to take the largest of those three numbers and I'm going to write that number in right here. So that number is 45,000. How about an unfavorable survey? So node 4 is minus 33,000. No shop is minus 5,000. And node 5 is minus 10,200. The largest of those numbers is minus 5,000. So I write that in right here. And then the bottom one, node 6 is 10,000. Node 7 is 10,000. And no shop is 0. So the largest of those numbers is 10,000. Next, I need to figure out the decision node for number 1 here for the favorable and unfavorable surveys. So I was given in my problem that there's a 60% or 0.6 probability that the survey will be favorable. I'm going to type this in right here, 0.6 probability of favorable, which means that my probability for unfavorable is 0.4. So my calculation for node 1 is 45,000 times 0.6 plus minus 5,000 times 0.4, and that gives me 25,000. So I'm going to write 25,000 right here. My decision then on whether to conduct the survey or not to conduct the survey is based on these two numbers here now. If I conduct the market survey, my EMV is 25,000. If I don't do the survey, my EMV is 10,000. So because I always go with the highest number, I'm going to choose 25,000, which means that I will conduct the market survey.